Alright, so let's start with implicit differentiation. Actually, let me back up a second. Let's look at the calendar so people online can see the calendar. This next unit has 2 sections in it, which you probably know right away that that's good news and bad news, right? It's good news because it's only 2 sections. It's 2.5, which is implicit differentiation. Sounds complicated. 2.6 is related rates. And that's it. But we'll spend 2 days on implicit, 2 days on related rates, 2 days on review, and a test. So the flip side to that is these 2 units or lessons, even though they're only 1 section of the book, are kind of complicated. They're kind of difficult. But that's why we'll spend a couple days on each of them, a couple days on review. So I think we'll be okay. So you be excited that it's only 2 sections, but be a little bit nervous because of what's in those sections. Implicit differentiation. So 2 big words there. Let's talk about what the words mean. Differentiation, I think you know what that word means. Take a derivative. So that's just fancy talk for take a derivative. So we know how to do that. I mean, not completely, not all the rules yet, but we got a pretty good handle on it after that last test, I hope. A lot of rules and more to come, but you got a pretty good overview of the big picture rules. So take a derivative. Implicit as opposed to, what's the opposite of implicit? Explicit. So explicit is when you have an equation solved for y, when you explicitly know that y equals whatever. Implicit means I don't have it explicitly solved for y. I've got to do some extra work. So they look a little bit different. The equation is not solved for y. So you probably didn't even notice because you didn't think about the other options. But until now, all of our equations were explicit equations. They were all y equals something. So you would take the derivative and you get y prime equals whatever the derivative is, or dy dx equals whatever the derivative is. That's not really going to work so well today because you're going to have y's in different places. So you won't have y prime equals. You'll have y prime kind of sprinkled in through the problem. The main thing we need to remember to do implicit correctly is the chain rule. So the Tootsie Roll Pop rule, the outside in rule, 1 layer at a time rule. Let me remind you of it with a silly example, although very conceptual example. If I want to take the derivative of a green triangle cubed, what's a green triangle? I don't know, it doesn't matter. Because what's on the outside is the cube. So I'm not worried about the green triangle yet. I'm going to use the power rule. So 3 times the green triangle squared times, I don't know what the green triangle is, but it might have a derivative. So I have to take the derivative of the green triangle. That's the chain rule. So that green triangle might be sine of x, it could be the square root of x, it could be tangent of x. Later it could be a whole bunch of different things. But whatever it is, I have to remember to include this last step, to chain on the last step of the derivative of the green triangle. Is that silly, dumb? You understand what I'm talking about there? Okay, mostly nods. Nobody was shaking their head no. So if we take the derivative, remember d dx just means take the derivative of y cubed. Well, y is sort of taking the place of our green triangle here. 3y squared, but we're not done. because y probably does have a derivative with respect to x. So times dy dx. So this extra stuff with y we haven't done before because we've not needed to do before. We always just had y on one side. And so the derivative of y was y prime, or dy dx. That was it. But today we're going to have y's doing some extra stuff as well. All right, find dy dx if y cubed plus y squared minus 5y minus x squared equals -4. What a lovely little equation that is. So let's go through and take the derivative of each of the pieces. So the derivative of y cubed, we just did that one. That's 3y squared dy dx plus 2y dy dx minus 5, but not just 5 because y has a derivative, dy dx, so 5 dy dx minus 2x. Now here's where if you get overboard, it still works okay, because if you're still thinking, well, chain rule, 2x dx dx. Well, I mean, you could write that, I guess, but dx over dx, that's 1. So you don't have to do it with x's, but if you do it with x's, you'll still be okay. You just have some extra stuff thrown in there. And then what's the derivative of -4? 0. Okay, so I have a lot of things with dy dx in them. So I think I have some algebra ahead of me here. I think I want to factor out dy dx from these pieces and move 2x to the other side. So I'll move 2x over, and then I'll factor out dy dx from everybody else. So 3y squared plus 2y minus 5. I'm trying to solve for dy dx, so let's just divide by all this junk that's attached to it. So dy dx equals 2x over 3y squared plus 2y minus 5. So all our rules still apply, but we have to use the chain rule, and we'll have to use some algebra. Let's try another one. Y squared minus x squared equals 4. McKenna, what's the derivative of y squared?
2y.
So that's partially correct.
The dy over dy.
Yes. So 2y, but you got to include the dy dx. So 2y dy dx. Tyler, how about the derivative of x squared?
2x.
And that's it. Good. I was trying to bait you into adding to that. You wouldn't take the bait. Yeah, so for the x's, you don't have to worry about it. Or you do worry about it, and you get dx dx. It doesn't matter anyway. Okay, so this one's a little bit easier on the algebra front. How many things can I do at once? Add the 2x over, divide by 2y, and I get x over y. So there's really no new derivative rules today. It's mostly power rule, but there's some other rules thrown in there too. The main thing is the chain rule. Use the chain rule for derivatives of y. 2x squared y plus 3y equals 5. Well, that looks like a product rule coming our way. 2x squared times y F and G. Those are simple enough. I'm not going to write them out. I'll write out the product rule here to help sort of guide my thinking a little bit. So F is 2x squared. What's the derivative of y? dy dx. Plus G times the derivative of 2x squared, which would just be 4x. So if that looks a little funny, but we can fix that later. So there's our product rule. Again, we know the product rule. We know the chain rule. We're just doing it a little bit different because we got dy dx showing up in multiple places. Aldrich, what's the derivative of 3y?
3 dy dx.
Good, 3 dy dx. Lauren, how about the derivative of 5?
Oh, it's
0. All right, now it's an algebra problem. So I'm going to move the 4xy over, factor out dy dx from what's left. And then divide by what's attached to dy dx. So again, we sort of expanded what we are able to take the derivative of. A couple more examples. So that was 3, so now we're on 4. I can do calculus, but I can't always count my examples. Find the slope of a tangent line. Okay, we've done enough of that to know that that's just code word for find a derivative. 2 x squared plus 4y squared equals 4 at root 2 comma negative 1 over root 2. Why don't you try that and see if you can get down to at least what dy dx equals to, and then if you have trouble plugging in, that's fine. Maybe you can take it all away. So I'm going to pause it while you see if you can solve that thing for dy dx. So there's the next step. 8y dy dx equals negative 2x. I divide both sides by 8y, I get negative x over 4y. And I'm not done because I want to find the actual slope, which dy dx is the slope, but I need to evaluate that at root 2 comma negative 1 over root 2. And you may not be familiar with that signage right there, or those symbols, but you put a bar, and down here you put what you want to, where you want to evaluate it. So this just means I'm going to plug in this point and see what I get. So negative root 2 over 4 times negative 1 over root 2. And as a free response answer, that would be perfectly acceptable. right? We don't need to clean up fractions or square roots or even the two negative signs. Just leave it. Who cares? On a multiple choice test, you know there's going to be some cleanup done on that. So I think on the bottom I'd multiply by root 2 to make the fraction go away, which means I'd have to multiply the top by root 2. So it's kind of nice, but doing that fixes everything all at once. So the fraction cancels. That's why we multiplied. That was the motivation there. So that's negative 4. And in the top, root 2 times root 2 is 2. So all that turned out to be 1/2. An ugly looking problem with a reasonable looking answer. And again, tangent line, but you've done enough of that. That's just us asking you to find the derivative and maybe evaluate it at a certain spot. It could have asked you to find the equation of a tangent line, and then we would have used the point and the slope. So you're starting to learn that we can ask the same thing a bunch of different ways. Find the instantaneous rate of change, something like that. All right, one more. Because we never want to miss an opportunity to find the equation of a tangent line. So it's pretty much everything we did in that last example, except we'll have to do that last step of putting it together. 2x equals sine y at 1 comma pi over 2. It's kind of a weird looking graph. X equals sine of y. Tangent line means that I need a slope and a point. Slope meaning m, but m meaning dy dx. And a point, they gave us the point. So our job, as usual, is to find the derivative. So derivative of x is 1. What's the derivative of sine of y? Is it positive or negative? Derivative of sine is positive cosine. Is anybody not satisfied with that answer? dy dx. Chain rule. For one, if you wrote right there, if you stop there, hopefully you'd think, wait a minute, I don't even have any dy dx. What's going on here? And the reason is you need to chain rule that. The derivative of y is dy dx. So dy dx equals 1 over cosine of y, which is secant, but no one's going to change that to secant because you don't really evaluate secant. You'd have to flip it right back to cosine. So just leave it as cosine at 1 comma pi over 2. Yeah, it turns out we don't even need the 1. It only depends on y. So 1 over cosine of pi over 2. Let's see, cosine of pi over 2. I got to draw the picture every time. Pi over 2 is up there. Cosine is the x-coordinate. That's 0. Uh-oh. What's 1 divided by 0? Undefined. That's a great answer. Because what we're looking for is a slope. But we just found a slope that's undefined. But that doesn't mean the problem is done, because you hopefully remember from Algebra 1, I walked into an Algebra 1 teacher's class yesterday, day before, and they had this kind of stuff on the board. What's an undefined slope look like from Algebra 1? Straight up and down. So usually we get 1 over 0 or 0, and in the bottom you say, oh, I can't divide by 0, we're done. And this time we're saying, well, no, we're not quite done. It is undefined, but undefined slope, that has a meaning. That doesn't mean we're just throw the problem away. Undefined slope means Vertical slope means the line is straight up and down. So it doesn't mean our problem is over, it just means we've got a vertical tangent line. Oh boy, now we're really going back to Algebra 1 here. What's the equation of a vertical line look like? X equals something. So x equals something. X equals something. Well, how am I supposed to know what x equals for this particular problem? So vertical slope means vertical tangent line. That means x equals something. But what does x equal? What does x equal in this particular problem? 1. So we go back. Our tangent line's got to go through this point. So this is a different looking tangent line than we're used to. But it's got to be x equals 1 if we need it to go through that point. So this is kind of a goofy, not goofy, well, I guess it's goofy, a weird problem. Because usually when you get 1 over 0 in math, you just stop and say, we can't do that. But now you answered undefined. Undefined slope has a meaning, means it's vertical, and we can write a vertical tangent line. Let me, I guess, clarify something here. Vertical tangent lines means slope is undefined. Means the denominator of y prime is 0. So yes, when you get a denominator of 0, you should be worried something weird is going on, but it doesn't mean the problem is over and you just write no solution. It means something weird is going on and you got to figure out what weird is going on. As opposed to horizontal tangent lines, where the slope is 0, and that would mean the numerator of y prime is 0. Again, this goes way back to Algebra 1, where students get so confused, and it takes a while, and maybe you were one that was confused for a little bit about, this is 0 slope, this is undefined slope. It doesn't mean there's not a line, it just means it's undefined slope versus 0 slope. And what that means, and now we see it again in calculus with the same stuff. Vertical means undefined slope. Undefined slope happens if denominator is 0. Horizontal, we've done some of those. That's the slope of 0, so that would be the numerator being 0. That'll help on some of the homework assignment. Page 145, 1 through 29 odd, and 33 and 35. And again, you're in section 2.5, so answers are on CalcChat. Plus, remember that CalcChat has the online tutor assistant person that can help.